Hi, I hope you're doing well. I am going to go over some of the problems for Module 3. Looking at the tests, and some of the questions I've been getting, it seems like a lot of the material was confusing or that we were struggling with some of the material. So I've chosen some specific problems to go over, um, and I will share this to modules. And you can let me know if you have any questions about any of the questions or the problems that I've chosen. I'm gonna share my screen and annotate on the computer so you can see the problems. Okay, so first problem is this. And the first thing we have is dividing rationals. So this test was about rationals, fractions, rational fractions. Um, and so this first part is dividing fractions. Okay. So when we're dividing fractions, the first thing we need to remember is copy dot flip. Copy dot flip. Okay. So with this first part, we're going to copy this first part, 3y to the 9th, x to the 6th, all over 14y to the 4th. Dot means multiplication, so change this to multiplication, and we're going to flip this second part. So it's going to become 3x squared over 5y to the 4th, x to the 4th. So now we're going to simplify. Some people try to jump to multiplication, and that does make it more complicated later because your numbers are bigger, everything's bigger. Whereas if you simplify first, it will make simplifying later a lot easier. So first I'm going to look at my numbers. I have a 3 on top here and a 3 on top here and a 14 and a 5. 14 is 7 times 2. And I don't have anything that can cross off or that simplifies to 1. So I'm just going to leave them all the way they are. So now I'm going to look at my variables. So I have x to the 6th here and x to the 4th down here. When I have x's in the numerator and the denominator, I'm going to subtract their exponents. So I have 6, sorry, I'll do it on here, 6 minus 4, and I get 2. So that's going to stay on top. So I have 3 times 3 gives me 9. X squared. And then I have this other x here. So I'm just going to leave that right here for now. And then I have this y here. So I'll do y in a different color. So we have y to the 9th and y to the 4th and y to the 4th here. So we're going to go 9 minus 4 minus 4 equals 1. So I'll have y to the 1. I'm always going to put them on the top. Even if they end up being negative, I'm going to put them on the top. I can move them down later when we're moving our negative exponents. Remember, you flip them to the opposite side of whatever they were on, numerator to denominator, denominator to numerator. Okay. And then all over, and then we have 14 times 5, and 14 times 5 gives us 70. Okay. So now I need to simplify just a little bit further because I didn't do those other x's. So those are all on the same in the same section. So they're both in the numerator. or if they were both in the denominator, you would do the same thing. But they're both in the numerator, so I'm going to add the exponents. So I have 9x to the 4th, y to the 1 over 70. Okay. If subtracting and adding exponents is confusing and you're not sure that you can remember that, or you're not understanding why we're doing that, another way to do it is to write out all your variables. So we have 9y's here, 6x's, 2x's, 4x's, 4y's, and 4y's. And what you can do is you can go through and you can cross off what cancels out. So I have 1, 2, 3, 4, 5, 6, 7, 8. So 8 of my y's cross off up here, and I'm left with 1, which is how we get this one over here. And then I have 1, 2, 3, 4, cross off with this 1, 2, 3, 4, and I'm left with 4, which is how I get this 4 here. 4 and 1. Okay. So if you prefer to do it that way, you can also do it that way. Okay. So that's problem number 1. Okay. Next problem. And again, if you need help with this, pause the video, try doing the problem yourself, or ask me if you have any questions. Okay. Okay. So this problem is similar. Also copy dot flip. Okay. But now we have equations. Okay. So we're going to work with, again, copy the first part. So x squared plus 6x plus 5 over x squared minus 6x plus 5 dot for the multiplication. And we're going to flip the last one. So x minus 1 over x plus 1. Okay. So now we're going to look to factoring these. This type of problem, you have to factor. Okay. So we have x squared plus 6x plus 5 factors to be x plus 1, x plus 5. The bottom factors to be x minus 1, x minus 5. And then we still have times x minus 1 over x plus 1. Now, just like previously, we're trying to find things that equal 1, but we can't cross off anything that is attached with an addition or subtraction. So only things that are being multiplied. So I can cross off this entire x plus 1 with this entire x plus 1. And then I can cross off this x minus 1 with this x minus 1. So then I'm left with x plus 5 over x minus 5. Okay. Okay. Next problem. I know I'm deleting all the information on it. I'm annotating with the Zoom, so I have to delete it before I move on. Okay, so next problem. Okay. So now we're solving the equation with rationals. Okay. So first thing we need to do is we need to figure out what is our least common denominator. Just like with any fractions, we need to find what that is. So our least common denominator, okay. First thing, we need to see if there's anything we need to factor. So here, this 2 can be pulled out, and I have 2x minus 2. This is really over a 1. It's important to remember your whole numbers as well, okay. So for our least common denominator, we know we need a 2 here for this part, and we need an x minus 2. And then this over here is covered by that x minus 2. So our least common denominator is 2 times x minus 2. So each part needs to have that. Okay. So there's different ways to do this problem. I'm going to do it the longer way because I think on the video it does it the shorter way. And if that's confusing, then you have both ways. Okay. So just like with regular fractions, you need to get a common denominator. So I'm going to multiply this. This has an x minus 2 here. So it needs just a 2. So I'm going to multiply this by 2. I'm not going to multiply that in. I'm just going to leave it on the outside because I can. Okay. I'm going to multiply this by 2. Okay. And then the 7 also needs to have the common denominator. So I have to have 2x minus 2 in the denominator and 2x minus 2 in the numerator. So now I have x over 2 times x minus 2 minus 7 times 2 is 14. And then we can multiply that 14 in. So I'll do that later. So I'll have 14 times x minus 2 equals, sorry, that's over 2 times x minus 2. And I apologize for the writing, looking a little poor. I am writing with my finger on my computer. And that equals 2 over 2 times x minus 2. Okay. So now I have all of these have the same denominator. Okay. With equations, if I multiply the same thing to both sides, it doesn't change the equation. Just like if I add the same things to both sides or subtract, it's the same thing for both sides. So what we're going to do is now we're going to multiply by that denominator. So I'm going to multiply this whole thing by 2 times x minus 2. And this whole thing is going to be multiplied by 2 times x minus 2. So when I distribute it on these, okay, this is going to cross off with this, and this is going to cross off with that. So then I just have x minus, I'm going to multiply that 14 in, and it's a negative minus 14x, so negative 14x minus 14x. That's a negative 2, so 14 times 2, negative 14 here, times negative 2 turns as positive. Don't forget your little subtraction there. That's going to trip some people up, okay? Negative 14 times negative 2 gives us positive 28, okay? Equals 2. Okay, so now we're going to simplify. Okay, so we have this x minus 14x, and we get negative 13x. Okay, we're going to minus our 28 over, equals negative 26. I'm going to divide by my negative 13. Sorry about that. Negative 13. We have x equals 2. Okay, so we think we're done. We think that's great. You always have to check your answer. So now we're going to check. We're going to go back to the original problem and we're going to plug it in to make sure that it's going to work. Okay, so I'm going to go 2 over 2 times 2 minus 4 minus 7 equals 1 over 2 minus 2. And the issue that we have is that 2 times 2, this is 4 minus 4, and this is 2 minus 2, this is 0. So we end up with 0 in our denominators, and that is not allowed, right? So that means this answer doesn't work, and we don't have any other answers. So that means our answer is D, N, E, or does not exist. Okay, do not forget to check your answer. Okay, first part is to solve, second part's to check. Okay. All right, next question. Okay, so there are a lot of terms and units with this problem. Okay, you don't need to stress about what they mean. Okay, you don't need to stress about what moles mean or grams, grams are, but you don't need to worry about what moles are, HCI, Cl2. You don't need to stress about what those mean. What we're practicing here is conversions. Okay, so first thing, we're going to start with what we're given. Okay, we have 83.57. So 83.57. And I'm going to simplify this. I'm just going to write it as G of H because my other one is G of C. Okay, so G of H, and that's all over 1. And I need to get this to G of C. So at the end, you're going to end up with G of C. Okay, so I'm going to put in what I need to so I can get those units away. They need to cancel out. That means I need to have whatever's in the numerator to cancel out, it needs to be canceled out with something in the denominator. The same thing needs to be in the denominator. So I'm going to find grams of HCI. So grams of HCI is right here. So that's going to go in the denominator, 36.46 grams of HCI. Okay, so these are all being multiplied. That is equal to 1 mole of HCI. I have to write that on the opposite side. Those things are equal. So what I'm really doing is I'm multiplying by 1. Because if I had 5 over 5, those are the same thing. I'm really multiplying by 1, and multiplying by 1 doesn't change anything. So that's why I can multiply by these. Okay, so then now I have moles of H. Okay, and we can see, okay, well, this is going to cross off with that. Right, that's what I want. So now I have moles of HCI. So my other one with moles of HCI is right here. So now I have 5 moles of HCI is equal to 3 moles of Cl2. Okay, so then these are gone. Then I need something that is moles of C. So moles of Cl2. So I have 1 mole of Cl2 is equal to 70.90 grams of Cl2. So these are crossing off. And then here we'll see out grams of C. That's what I need. So now we can solve. Okay. When doing this in your calculator, everything in the numerator gets multiplied. Everything in the denominator gets divided. So you can do it different ways. You can do it all the multiplication at one time and then all the division at one time. Okay, or you can do 1 and then 1. That's fine. Okay, so I'm going to go 83.57 times 1 times 3 times 70.90. Then I'm going to divide by all the stuff in the denominator. Divide by 36.46 divided by 5. Divide by 1, but those don't do anything. Okay, and you end up with 97.50597. Okay, now if it doesn't specify what to round to, then do a couple decimal places. Okay, but you're not going to get marked wrong if it doesn't specify what you're going to be rounding to. Okay, but in a general sense, I just like to do 2 decimal places unless it tells me otherwise. Okay, so now we have 97.50. If I want to round to 2 decimal places, I'm going to go to this third one. It's a 5. 5 and above makes me round the number before it up 1. So that's going to be 0.51. That 0 turns to a 1. And that's our answer there. Okay. Awesome. Okay. Now these conversions, okay, you are given all the information. On the other conversion problems, you can use your conversion chart that is in the workbook or that I have attached to Canvas or that I've sent out to you. Okay. So I will email that out again. Okay. But I'll pull it up so you can see what it looks like when we get to a problem like that. Okay. Okay. Next problem. Okay. So this type of problem, okay, we have fractions within fractions. Okay. I know this looks a little scary, a little confusing, but what we're going to do is we're going to look for our least common denominator for every fraction that we have. So here we need to have an A. Okay. We need to have a 7 for that next part. Looking down here, we need to have an A. We already have an A, so that's taken care of for that one. Okay. And we need to have a 4 here. So our least common denominator is going to be 28A. So what I'm going to do is I'm going to multiply the numerator by 28A and the denominator by 28A. The reason why I can do this is because 28a over 28a is 1. I'm multiplying by 1. I'm not changing the problem. I can't just multiply by anything and not do it to both parts. I have to do it to both parts for this to be allowed. Okay, we're not changing the problem. Okay, we're just simplifying a different way. So when I have this, I'm going to multiply this in. Okay, and this is the step you might skip. Okay, but I'm going to show it so that we understand what's happening. So I have 28a over a plus 28 times 2, and I'm not going to multiply it yet. I'm just going to write 2 times 28a over 7, and you'll see why. All over, going to multiply the 28 now to these two. So I have 28a over a plus 3 times 28a over 4. Okay. So before I start multiplying everything, I'm going to start simplifying. Okay. This a and this fraction disappear, cancel out, simplify to 1. Okay, this one over here, I have a 7 that can go into this 28. 28 is 4 times 7. So I can multiply that or divide that 7 out with that 7, and I'm left with 2 times 4 times a. Okay, this a can cross off with this a, and again, this is 7 times 4, and this 4 with that 4. So I'm left with 28 plus 2 times 4 is 8. And then I have my a all over 28 down here. The a's crossed off, plus 3 times 7 is 21 with an a. And that's your answer. Okay. So first, least common denominator, multiply by it, simplify what needs to be simplified, and you have your answer. Okay. Okay. Next problem. Very similar, but now there's whole numbers. Okay. You're going to treat them exactly the same. This is really over 1, and this is really over 1. So my least common denominator, okay, here we have 1. We don't need to put that because that doesn't change anything. And then, so here we have an a that needs to be down there or in there. So then we look at this one, that's a squared. So one of those, that a covers one of those a's. This is a times a, but I still need to have another a to cover the other one. Okay, so my least common denominator is a squared. So I'm going to do the same thing. I'm going to multiply this by a squared and this by a squared. Okay, and I might skip this step here for this to show you. So when I multiply these in, 3 times a squared. Okay. We have, yeah, we're going to do this way. 3 times a squared, we have 3a squared. 21 times a squared, but that a is going to cross off with one of these a's. So then I have plus 21a all over, and that a squared is going to be multiplied in. So I have a squared, and then that a squared is going to cross off with this a squared. So then I have minus 49. Okay. Now, this is a special problem, okay? Because it looks like we're done, but it says simplify completely. So now we're going to see if there's anything that we can simplify, factor, greatest common factor. Let's try those things. So for this part, I can pull out a 3 and an a. My greatest common factor up top, 3a. So then I'm left with an a, 1a, plus 7. Okay. Then I'm going to look at the denominator. A squared minus 49, that is a perfect square. So I can factor it to a minus 7, a plus 7. So these can now cancel because everything is being multiplied here. And I'm left with 3a over a minus 7. And that's as far as we can simplify there. Okay. All right, next problem. I'm going to stop my share real quick so I can pull up my conversion chart so I can show you the conversion chart that you guys can use. Okay, so here's the problem. Here's a conversion chart. Okay, so you can use this on your test. Okay, so that means you need to have it printed out and you need to show me in your video I have my conversion chart. Okay, so it's double-sided. Okay, formulas here and your conversions here. Okay, so for this problem, we say we have Danica is traveling in a train at a velocity of 61 miles per hour. Find the velocity in meters per second. Okay, so with our conversion, we're starting with 61 miles. Okay, and I'm going to write miles because we're working with miles and meters, so don't get confused by the two M's. Miles per 1 hour. And we want meters per second. Okay, so first we have, I'm going to choose one to change. Okay, so I'm going to go from miles to meters. Okay, so I need to figure out where we are going from miles to meters. Okay, so here we have miles. Okay, I'm going to change it to feet. Okay, because that's what I got there. And then down here, we're jumping to inches to centimeters, and meters isn't until over here. Okay, so I'm going to go from miles to feet, and then I'm going to go from feet to inches. Then I'm going to go inches to centimeters, centimeters to meters. Okay, that's a lot of steps. Okay, but you have your conversion chart here. Okay, so just remember each part that you need to multiply by. Okay, so 61 miles per hour. I'm not even going to worry about the hours for now. We're just going to leave that there. Okay, so miles, I need miles gone. So I know 1 mile is equal to 5,280 feet. Okay, every time. Okay, this miles, cross off with that. Okay, I'm getting closer to what I need. Okay, and then I'm going to multiply. I need feet gone. So I'm going from, I have 1 foot equals 12 inches. Okay, that's gone. Okay, and then I need inches gone. So inches, I have 1 inch is equal to 2.54 centimeters. Okay, and that's gone. Then I have centimeters to meters. Okay, so I have 100 centimeters is equal to 1 meter. And that's what I need, 1 meter. I need meters here. Okay, so my centimeters is gone. Okay, so now I got meters, but now I need to work with seconds. So I'm going to work with the other one. Okay, so if you didn't remember, here's the time. Okay, I'm starting with hours. I'm just going to start a second line here. So hours is in the denominator. That means for it to cancel out, I need it to be in the numerator. So I have, and this is going to be kind of weird because I'm doing it on a second line. Okay, but imagine that it's all on one line if that would help you. Okay, so I have 1 hour is equal to 60 minutes. Okay, so then this hour that's in the denominator here is crossing off with this hour that's in the numerator. Okay, times or multiply by 1 minute is equal to 60 seconds. And that's what I need, seconds. So this here, minutes is crossing off. So I have, and always check that you have your meters, you have your correct units, meters over seconds. Okay. So we're going to do it in our calculator. Make that look a little better at least. Okay. All right. So in our calculator, we have sorry about that. Okay, so we're going to go 61 times 5,280 times 12 times 2.54 times 1 times 1 times 1. I'm not going to do those. Then we're going to divide by everything in the denominator. Divide by 1, divide by 1, 1, 1, divide by 100, divide by 60, divide by 60. We end up with 27.269, okay? And again, this one doesn't specify. This time I'm going to do it to 3 decimal places. Okay, so we end up with 27.269. Okay. Okay, and again, you can use the conversion chart on your test. You do not have to memorize these. Okay. All right. Next problem, and this is the last one, is finding the least common multiples. Okay. Finding the least common multiples is like finding a common denominator. Okay. First thing, we need to factor these. All right, so here we have x squared plus 8xy plus 15y squared. Okay, so x plus 5y times x plus 3y. Okay, and you can FOIL that back out and check it. Okay, 5y times 3y gives me that 15y squared, and 5yx, 3yx added equals 8xy. Okay, so now we're going to look at this one. Okay, factoring that, that's a difference of squares. Okay, I think earlier in the video I said perfect square. I meant difference of squares. So we have x minus 5y, x plus 5y. So when we're looking at our least common multiple, we need to have everything covered. So we need an x plus 5y. We need an x plus 3y. We need an x minus 5y. We need an x plus 5y, but we already have that, and that's being covered by that because there's only one. If there was another one, we'd have to add another one down there. But there's only one. So this is our least common multiple. Okay. So throughout the video, if I went too fast, pause the video, work out the problems yourself. Let me know if you have any questions. Okay, I'd be happy to help. Okay, good luck. Okay, you'll do great. Bye.